Hello students, hope all of you are well. So today I welcome all of you in the next lecture regarding the change of order of the integration. So this video lecture is going to be one of the most important video lecture for your exam. So please follow all the problems very carefully. Now in my previous video lecture already I have told you about the double integration for constant limit case and the double integration and triple integration for the variable limit case. So why the change of order of integration is required? So basically whenever we do the integration over a region or over a volume, sometimes we face the difficulties for the limits of the integration, particularly whenever the limits are given in a variable limit form. So there will be some complexity in the integration that cannot be done very easily, or finding the limits also will not be very easy to identify. So to overcome this two types of reason, we have to change the order of the integration. Now how to change the order of the integration? Basically whenever we will change the order of the integration, then the integrants will interchange their position. Suppose we are having one integration when we can see x is varying from x equal to a to b and y is varying from function of x to function of another function of x, f of xy, first dy then dx. But whenever we will change the order of the integration, then the x initially was a constant limit, now x will become the variable limit, that will be function of y, and y will become constant, and the integration also will change its order. First with respect to x we have to do, then with respect to y we have to perform. So it means we have to change the order of the integration. In which order we are performing the integration, that order we have to change to sake of the simplicity, or to avoid the complexity of the problem. Now one most important thing you have to remember, that while doing the change of the integration, it does not mean that you just interchange the integral. While we have seen most of the students do the mistake, they just interchange the integration but not changing the limit. Based on the region itself, the limits also are going to be interchanged. So that is the most important part of this change of order of integration. Now let us come to discuss through the problems. From the problem itself we are going to understand the concept very easily. So the first problem that I have chosen here, that is evaluate integration 0 to a and integration y to a x into dx dy x square plus y square. Now you can see the first integration that we have to perform with respect to x, which is having the limit y to a, and thereafter we have to perform with respect to y. So y is having the limit 0 to a. So first of all we have to note down this thing. So limit of x is from y to a and limit of y is from 0 to a. So for doing the order of change of order, the most important part of this integration will take on the diagram. So based on the limits we have to do or perform the diagram. So here the first diagram we have to draw based on the limit provided. So here we are having x equal to y. So x equal to y is a straight line that you can see here, and x equal to a. So x equal to a is the line which is parallel to y-axis. Y equal to 0, y equal to 0 means x-axis, and y equal to a, that is the line which is parallel to x-axis. Now here most of the student make the confusion, since we can see two different triangles are there, so they are become confused while choosing the triangle. Now to choose the triangle you have to identify the rule that I have told you already in the previous video lecture, that whenever we think about x is measured along the horizontal direction and y is measured on the vertical direction. So here limit of x says that x is going from y to a. right? X equal to y, this is the line. From this line x is start its measure and it will finish at a. So basically we have to shade this region by the horizontal lines. So this is the region on which basically we have to perform the integration. So for this region, so you can see it starts from 0 and it will end at this line. So the coordinate of this point is a comma a. So y is varying over this region 0 to a, which is given in the second limit, and x is varying from y to a. Basically x equal to y, x will start from y and it will go up to x equal to a. So this is the diagram that we are given. It is given in the question. Now the same diagram we have to redraw and we have to change the limit. So how to change the limit? The same diagram we have drawn, y equal to x, y equal to a, and x equal to a. So previously we have shaded the region by horizontal line. Now to change the order of the integration, we have to make x as constant and y should be variable. So since y is variable, y we measure along the vertical direction. So the same region we have to shade by the vertical lines. So this is the rule. If you can understand this rule, then every problem will be simple to you. So here now what is the measurement of x then? So x will start from 0, maximum x will go up to this point a comma 0. So what will be the limit of x? That is the variation of x we can see. So 0 to a. So limit of x is going to be 0 to a. What will be the limit of y then? Since we are measuring y vertically and y is starting from x-axis. On x-axis the value of y is 0, and on the line maximum y can go up to this line because this is the region, it cannot go beyond this line. So on the line the value of y is x only. So limit of y is from 0 to x. So what we can see, initially x was having the variable limit, y is having the constant limit. Now after changing the order of the integration, we have not changed the region itself, we are just changing the limit of the variable so that the same region can be traced down. So limit of x is now becoming constant and limit of y is becoming variable. So with respect to this concept, we have to find out the rest of the integration. Now let us come to the solution part. So now you can see initially it was given 0 to a, y to a, x into dx dy divided by x square plus y square. Now you can imagine also, if this is our integrand, that is x upon x square by y square, we have to integrate it with respect to x, then it will be little bit difficult to solve. We have to make some substitution, and after the substitution y value can becoming vanish. So that will be the difficulty. So we have to change the order of the integration. So initially this was the limit. After changing the order of integration, we are having x equal to 0 to a, x limit is constant, so it will be outside integration. Since y limit is going to be variable, so y will go inside. Y limit is going to be 0 to x, x upon x square plus y square, first with respect to dy, thereafter we have to perform with respect to dx. Now to do this integration, x is treated as a constant, so x we can take outside of this integration, so it is 1 by x square plus y square. Since x square is constant, so we can apply this formula of the integration, that is dx upon a square plus x square. Everyone know the rule of this thing is that 1 upon a tan inverse of x by a. So we have to apply this rule. In place of a we are having x, in place of x we are having y square or y. In place of x we have y. So we have the answer as 1 upon x tan inverse of y upon x. limit of y we have to put 0 to x. Now whenever we put y equal to x, tan inverse of x upon x, it will become tan inverse of 1. Tan inverse of 1 is nothing but pi by 4, and this x and x are going to be cancelled out. Now you can see the integration becomes more easy to solve. So pi by 4 is going outside, integration of dx only. Dx integration is x, upper limit is a, so the answer is coming pi a upon 4. Let us come to the next integration, next problem, to understand it more easily. Little bit complicated one. Now the limits of the integration is given in this question as 0 to infinity x to infinity e power minus y divided by y dy dx. So you can see this is a very complicated integrand to solve with respect to y. Now since it is given the first integration with respect to y, so definitely it is the limit of y, and this one is the limit of x. So first of all we have to identify the limits, based on which we have to draw the diagram. Thereafter we have to change the order of the integration. So these are the steps that you have to remember one by one. So first of all we have written the limit of x, which is the outside integration 0 to infinity. So here it is treated as a constant limit of x. Now y is a function of x, so y limit is variable. Initially it is given in this manner. So y varies from x up to infinity. So let us try to draw the diagram and understand how to change the order of the integration. Okay, so here on the left hand side, the first diagram that you can see here, x axis, y axis, x equals to 0 means the y axis, x equals to infinity, so it will be infinity, infinite value, so it will be further to this side, right hand side, and y will start from x, and y will go up to infinity. Again the confusion the students can have, which regions are we will going to select. Basically you have to understand from the variable limit itself. So here what it says, y is ranging from x to infinity. So y is starting from x and then y is going up to infinity. So basically y is variable, and y we measure by vertical lines, which so this is the upper half of the portion that we have to shade. So this is the region over which the integration will take part. Now the same diagram we have to redraw. So y equals to x is the line, x equals to 0, that is our y axis, y equals to 0, this is our x axis. Now since we have to make the limit of x is now variable and limit of y is going to be constant, so since limit of y is going to be constant, so and limit of x is going to be variable, so the same shaded region we have to redraw, but not with the vertical lines, since we are measuring x with the horizontal portion, so we have to shade the same region by horizontal line. So from the diagram you can be able to understand from where x is basically starting. So x is starting from 0, but x is going up to y only, because this is the line over which x equal to y, it cannot cross this line. So what will be the limit of x? X will start from 0, it will go maximum up to y only, and y will start from 0. Since there is no upper limit, it will go in the upper side, so y is going to be 0 to infinity. So before we change the order of the integration, you can verify this. Initially x was having constant limit, y was having variable limit. Now x is becoming variable limit, y is having the constant limit. Now we will come to the solution part. So here the integration is that I equals to 0 to infinity x to infinity e power minus y upon y dy dx. So here we have to now change the order of the integration. So since y limit is constant, so y limit will be the outer integration So y equals to 0 to infinity, it will go outside. X limit is going to be variable, so the inner integration will happen with respect to x. So x limit is going to be 0 to y e power minus y by y. First of all, we have to do with respect to x, then we have to perform with respect to y. So since we are first performing with respect to x, so e power y minus y upon y, this full term will be treated as constant because we have to perform with respect to x only. So e power minus y upon y we can take out of the integration of dx, result is x only, limit is 0 to y dy. So if we replace x by y, putting the upper limit here, so y and y, this y and y will get cancelled out and we are having e power minus y. So integration of e power minus y is minus e power minus y. We should not put limit infinity directly. Basically we have to take limit y tends to infinity outside, make this thing is constant. So that is no need right now. For your understanding, you can do in this way also in your exam. So minus e power minus y 0 to infinity, whenever we'll put infinity here, it will become e power minus infinity. So basically it is 1 divided by e power infinity. There is a huge number, so e power minus infinity will become 0. Minus of minus e power 0 equals to 1. So result is going to be 1 only. Let us come to the third example. So here also we have to evaluate an integration using the change of order. So the limit are given as 0 to b, 0 to a upon b, b minus y, x into y, dx into dy. So as per the given integration, you can see the first limit is given for x and the second limit is given for y. Okay, so here x basically is having the variable limit and y is having the constant limit. So let us write down this concept first. So x is varying from 0 to a upon b, b minus y, and y is varying from 0 to b itself. Now many students get confused for this part, so I have done it separately to make you understand. So x equal to a upon b, b minus y, what does it represent to us? So let us just simplify one line. So it will become bx plus ay equal to ab. Now if we divide both sides by ab, we are having x upon a plus y upon b equal to 1. So basically it represents a straight line in the intercepted form. Okay, so let us try to draw the region now. So here you can see the left hand side region diagram that we have drawn for the given limit only. Okay, so now what are the limits? We can see x is varying from 0 to this straight line, the x by a plus y by b equal to 1. So x by a plus y by b equal to 1. This will be the straight line. This straight line will intersect x axis at a point a comma 0, and this straight line will intersect y axis at a point 0 comma b, and y equal to 0 means basically our x axis, x equal to 0 basically is our y axis, and y equal to b is a line which is parallel to our x axis. Now which region should be chosen? Now I think all of you can understand, from the variable limit itself we have to identify the region. So x is starting from 0, it is going up to the straight line. So x is starting from 0 and it is going up to the straight line. Since x is varying here, so we have to shade the region by the horizontal lines. Okay, now we have to redraw the region again, but now what is our plan? Our plan is to make x as a constant limit and make y limit as variable. So to make y limit as variable, the same region we have to redraw and shade it by the vertical line for our well understanding. So here this is the location of the point a comma 0. So for this region, what should be the range of x? We can see for this shaded region the x is varying from 0, maximum it is going up to a comma 0. So x limit is going to be 0 to a, but y is starting from 0 and y is going up to the straight line, right? So what is the value of y on the straight line? So it will go up to b into 1 minus x upon a. How I can write down this? From this expression I have made the calculation for you, so you can see x upon a plus y upon b equal to 1. From here, if we want to find out y, the value of y is going to be b into 1 minus x by a. Okay, so y is varying from 0 to this value. Y limit is going to be variable. So before the changing order of the integration, it is y equal to 0 to b, x equal to 0 to a upon b by b minus y xy dx dy. Now after changing the order of integration, x limit is going to be constant, so it is going outside, x equal to 0 to a, and y limit is going to be inside, y equal to 0 to b into 1 minus x upon a, xy dy dx. So since we have to perform first with respect to y, so we can treat x as a constant. So x is going outside, integration of y is y square divided by 2. We have to substitute the upper limit minus lower limit in place of y. So I have done this. So after doing this calculation, b square by 2 is coming as constant, so we have taken b square by 2 out of the integration, and x is multiplied with 1 minus x upon a whole square. So I have break this term a minus b whole square form. Thereafter we have taken x multiplied with inside, so we will get this structure x minus 2x square by a plus x cube by a square dx. So this term we have to integrate with respect to x and substitute the limit. So after doing the integration and substituting the limit, we are having the answer of this solution as a square plus a square into b square divided by 24. Now let us come to the next and the last problem of this whole lecture. The same type of equation, same type of problem it is, that is we have to change the order of the integration. Thereafter we have to evaluate this integration 0 to 4 x square by 4 to 2 root over of x dy dx. So first this is the limit of y and x limit is 0 to 4, that we have to write down here. Y equals to x square by 4 to 2 root over of x. Now y equal to x square by 4, what does it means to us? That is x square equal to 4y. So it is a C type parabola, right? Sorry, U type parabola. U type parabola. And y equal to 2 root x, so whenever we make it square, we are having y square equal to 4x. That is a C type parabola. U type, C type means the structure is looking like U and C. It is easy to remember. Now let us come to this left hand side diagram as per the given limit. Okay, so this is our x axis, this is our y axis, this is the U type parabola, and this is the C type parabola. So in between this portion is our the required region. But how to shade this region? Because y is of a variable limit, and we have to shade the region by vertical lines because y is variable. So for this region we have to shade this region by the vertical lines. Okay, now this is the 4,4 point. From here if we draw a perpendicular, it will meet the x-axis at a point 4,0. The same diagram we have to redraw again. So this is the coordinate of the point 4,4. We have to draw a perpendicular here. This is the point having coordinate 4,0. So what is the range for x? We can see here x will vary from 0 to 4. Right, x is vary from 0 to 4. Similarly, we can draw another perpendicular from here to y axis. So this will having the coordinate 0, 4. So y will also vary from 0 to 4 for this region if we want to make any one of the limit as a constant limit. Now the same region we have redraw, but here what we want, our desire is that initially x was having constant limit, y was variable, but now here what we want to make y limit as a constant and x limit as variable. So for this region, definitely y limit is going to be 0 less equals to y less equal to 4. So 0 to 4, that is the variation of y, but we have to make x as variable limit. So to make x as variable, we have to shade the region by horizontal lines. So the same region we have to shade, but with the horizontal lines. Okay, so in the top of the parabola, this is the parabola where we are having y square equal to 4x, and the green line, that is the lower parabola, that is x square equal to 4y. So if you look at these lines, so basically this x line is starting from this C-type parabola. So on this C-type parabola, what is the value of x? It is going to be y square divided by 4. And on this green color U-type parabola, what is the value of x? It is going to be 2 root y. So what will be the limit of x? So x will vary from y square divided by 4 to 2 root over of x. 2 root over of y. It is going to be 2 root over of y. Okay, now let us come to the calculation. So initially we are having the integration 0 to 4 y equals to x square by 4 to 2 root over of x. Now the limit of y is going to be constant, so it is going outside, and limit of x is going to be variable, so it is coming inside. X equal to y square by 4 to 2 root over of y. So first we have to perform with respect to dx, and thereafter we have to perform with respect to dy. Since no function is there, so we will treat function as 1 only. So integration of dx is x. We have to substitute the limit 2 root over of y minus of y square by 4. Now everything is coming in terms of y only, so we can integrate this one with respect to y and put the limit of y as 0 to 4. So after doing the integration of root over of y, there is basically y to the power 1 by 2. So limit integration of y will become y to the power 3 by 2 divided by 3 by 2, and y square divided by 4, it will become y cube divided by 3. 3 into 4, it is going to be 12. Now we substitute y equal to 4, so we are having this one, and y equal to 4 here, so we are having this one. Okay, now the final result is going to be 16 upon 3. This is one of the most important chapter for your upcoming exam, so practice all the problems very carefully. Next video lecture we are going to learn about the conversion of a double integration from the Cartesian coordinate to the polar coordinate. That is also going to be very interesting and important for the exam. Thank you all.